let's start without any further ado. So there were questions on the, so people had doubts on how the greater equals 3 works. So I'll just take a moment to explain that again and why that greater than sign is of significance. So the equality, just equality will not work. So I can just, I'll just give you an example to illustrate that. So just think about a case when, let's say, you have 2 1, so this gives you 1 3, right? Now let's create a 0 here. But how will, the way I will create a 0 is, I will make the product go to 3, and then I will subtract 3 from it. Let's say we have another 3 here, so this can become, let's say you're another p, and we want another p. So let's say you, now you can just have anything, let's say 1 1 1. Let's say this is the array. Now in this case, if you run the example, how much will count become? Anyone? If you remember, we used the count variable to count the total number, right? So what will be the value of count if we you run it for this example? 4, right? And it is actually possible to partition it into 3 parts, right? Let's say this can be one part, this can be another part, and this can be another part. So this entire thing can be one part, but this is 0, right? So this is 3 3 3. So this is what I was talking about. This entire thing can be one part, p1, right? Do you get? Get it now? I will have to mute whoever that is. Okay. Do you understand this? Should I explain it? So this is what I meant when I said the count. Why will the count be? The count will be 4, right? It will be 4. It will be 4. It won't be 3. Suraj, the count will be 4 because
Sir?
yeah.
Yeah, aren't we resetting, like whenever we have the condition satisfied that the current sum is equal to the required sum, aren't we resetting current sum to 0 again in the code?
Yeah, we are. So let's see. Let's just try run it. So we are starting from here. When we are here at this index, our current sum has become 3. So your count will become 1, and we will now reset the current sum to 0 again. Okay. Now I will again continue from here. So now the current sum becomes 2. Then if we proceed by one more, it becomes 3 again here, right? So now the condition is again met, and the count is incremented again. So the count becomes 2 now, and the current sum is reset. Okay, I get what you're saying. And then if we start from here again, it will be 0, correct, till here. Right. I get you. Here the count will still be 3. My bad, not 4. All right, let's do that exercise then. Let's uh, replace 3 and minus 3. Yeah, that's what I was about to do. What if you have this? That's what I was. If you have 3 here, and if you have minus 3 here, then what happens? It will still be 3 month away. It won't be 4, right? Because you will reset it here, and then this entire segment becomes 0. It is not 4, right? Yeah. Let's do one thing. Let's just submit that code with that equality sign. Is it getting accepted? Let's do this. Okay. Let's see. For 1 minus 1, that case, I guess there will be an issue. At 3 and minus 3 at the end, will it affect? Okay. Simran, you are talking about your example or Ankit's example? One minus one, yeah, this one, right? This will give you more than 3. Let's take up Simran's example, which is basically, this is, yes, this is a corner case, of course. 1 minus 1, 1 minus 1, 1 minus 1, 1 minus 1. Yeah, here the problem is because your current sum is 0 by default when you're initializing it. Your required sum here is also 0, right? So now, if you iterate through this, here it will count will increase by 1. Then here again, yeah, here it will increase by 1. Here it will increase by 1. That's only because the initial value. That's only because the sum and 0 both are the same. So if you remember, if we need 3 partitions with equal sum, any other partition, if that sum is also 0, so let's say these are the partitions P1, P2, P3, and this partition sums to 0. So then your count becomes 4, right? I mean greater than 3. Because if this sum is also 0, this sum is also 0. Yeah. Is it fine? Simran is right. This is the case for which it becomes greater or equals 3.
Got it, sir. Got it.
Shall we move on? Any more questions in this? Yeah. Okay, let's move on. So let's continue with the question that we were looking at and see if, so this is the question. Just bring your minds back to this question. And so this question, I want to show you another implementation of the same algorithm. This is the algorithm. Basically, we will pre-compute the suffix product as well as the prefix product, and we will then compute the result through this. But I want to get rid of this ternary expression, and I don't want if else's. So I'm just trying to show you a neater code. So what we can do here is, we can you unmute yourself, whoever that is? Mute yourself, I mean. Thank you. So just follow another implementation of the same algorithm, wherein I will get rid of this ternary this messy stuff. So what I'll do is I will initialize suffix prod to of size n plus 1. Now just follow along. So suffix product is also an array which will be of the size of nums, but I am just making it of size 1 more than the nums array. And that's because I want to use I plus 1 or I minus 1 for 0. So I want to use I plus 1 for n minus 1 for I equals n minus 1. So I plus 1 for I equals n minus 1 will become n, right? So I want to have that index. Similarly, I want to have this index, which is I minus 1, which is 0 for 0 also, for the first element also. So just see the code. I think it will become clear to you. Now the initialization of things to 1 becomes important. How? So now I can simply write suffix prod I. I will just do this equals. So if I want to do and for coming from the left, what I'll do is I will start from 1 to n, and I will just explain you this, don't worry. I will get rid of this. So this will give me do you understand this part? I will just explain it to you. So what I am trying to do now is another implementation is so the same example, what I am doing here is, so this was my nums array, actual array. Let's say this was of size n. What I'm doing is the suffix array. I know that there will be a boundary case for this, for the last element. What will be the boundary case? For other elements, I know that let's say I want to compute for this element. What I do is I have already pre-computed for this entire half, which is this value. So I will simply multiply this value with this number, and that will give me this value. That's what I am doing, but it's only for the last element. I don't have anything to the right, and I want to get rid of that. So for that, what I'm saying is I will allocate an array of size n plus 1, which the indexing is still from 0 to n minus 1, and this is n. And now I will initialize everything to 1. So this is also initialized to 1. So now I can simply start my loop from here and go come from the right and simply multiply whatever is to the right into the number. Do you see this? What I am trying to say here? Did anyone understand this? It's fine to say no. I can explain again. Yeah. So this basically helps me get rid of the dirty ternary expression or any if else's that I don't want to like make my code dirty. So similarly, for the prefix, the idea is analogous. I know that 0 is the boundary. For 0, I don't have anything to the left. So what I will do is prefix for nums 0 to n minus 1, I will store in prefix of 1 to n. So this one will be actually store the product till 0. This 2 will store the product till 1, till index 1. That's what I will do now. So this half is actually my answer. Here, this half was my answer, 0 to n minus 1. Here, 1 to n is my answer. And I can again initialize this with 1. And now I can simply use the for loop. Do you get this? Anyone? Is there any doubt? Is anyone not following? You can tell me. Feel free to speak up. It's fine. Nobody is. Because I'm getting only 3-4 acknowledgements. I don't know what 47 people on the other side are doing. Like I have no other way of knowing whether you follow it or not. I cannot see your faces. So yeah. Anwar, do you follow? Gaurav, do you follow? Gautam, do you follow?
Yes, sir.
Okay. So this is what I have done. Now tell me, what will I do for the result? Result also I have the boundary cases, right? So for result, what can I do? Any ideas?
Yes, sir. We can use a product variable in which we can store the product of the left two elements to the in our index. Like for the first element, we can use one in the product variable. Then we just multiply with the variable in the left.
Yeah, that's an optimization. We will see that. But let's actually first submit this code and see. So this is what I have done. I have gotten rid of the ternary expression, at least for these two parts. Now how will this change if I were to? So my result I is basically I can use, I'll have to use this because see one way of doing it, and for this is fine, right? Is this fine or is there any issue now? Anyone? Do I need to change anything? Can you tell me what went wrong? What do I need to change? Prefix prod I. Yes. Okay. So now just I want to now let's talk, we want to optimize it further, and I don't want to use this prefix array. So for this, I will just try and use the idea that I illustrated in the first question, which was basically, if you remember in the first question, we saw a way of computing the sum, cumulative sum, right? You can initialize the cumulative sum to 0 and you can keep adding whatever is there. So you can do a cur sum plus equals whatever the value is there, right? This will basically give you the current cumulative sum till this point. Can I use this to get rid of, use this idea basically to get rid of the prefix prod? I don't want to use this. Can I get rid of this? Anyone? How? Can you unmute and speak? Can I keep the prefix product in a single variable instead of keeping an array. So in the first pass, I will compute the suffix product by coming from the right. In the second pass, can I compute the result straight away directly by using the idea of the previous question anyways, and getting rid of this prefix product? I don't really need this variable. Can I just keep a running variable, which is, let's say, prefix prod? This is a variable. This is not an array, which I can keep updating as I go from left to right, similar to this sum. And at any point, I can use that product so far into whatever is to the right, which is there in the array, to compute the result. I will show you the code, and things might become clearer to you. We will see if it doesn't. So what I'm saying here is, I have the suffix product, cool. I don't want this product. I can just have a prefix prod, which is just a variable initialized to 1. And now I don't need this. Instead, what I will do is, I will start from the left again. Now I am computing the result also simultaneously. What I will do is, I can compute the result as simply the prefix prod of so far into suffix prod of I plus 1, and I can update my prefix prod. I'm sorry. Do you get this idea? Just stare at it. I haven't taken care of the corner case when I is n plus 1. That is, I will take care of, or I have I haven't, but I think I have, right? Is this code fine? Do you follow this? Let me just try it. All right. Does everyone understand? Shall we move on? Or does anyone have any questions so far? So I just got rid of the, you can see the code for people who still have doubts. Okay, so let's move on. Yeah. Let's talk about another question. So this is basically, I've just used the idea of the previous question. And in this question, I wanted to illustrate this particular idea of storing the prefix or the suffix values, either the sum or the product, which is basically, which will come haunt us again, don't worry, in some time. Let's do another question then, if things are clear to you. Yeah, let's try a specific implementation problem, which is this. So has everyone read it? Do you have any ideas as to how to go about doing this? Yeah.
Sir, I think we can store a single digit at a single index for solving this type of problem.
Yes. So, but will you multiply two arrays or?
Yes, sir, we can do that with one by one by multiplying each index with.
Yeah, can you do a simpler version wherein you can use one number and one array? Right?
Yes, sir, we can do that.
That might be simpler.
We store the result into the array and number a single number as a
Yes,
single
the
digit.
running, yeah, not the single digit, a single number basically. If you're doing
Yes,
n
sir.
factorial, if you can do n into, let's say you have computed n into n minus 1 into n minus 2. This product is in an array, and now you can multiply it with n minus 3. Again, the product will become in that array, and then you can multiply that with n minus 4 again. Right? That number with an array basically.
Yes, sir, got it.
Anyone else? Have you guys read it? What is the problem in just multiplying them, multiplying all of them, all the n numbers? The result is too big to store. So just, shall I start? Has everyone read it? I will start. So the problem here is that every data type has a specific limit. So an integer has a specific limit. You cannot store any number in an integer variable. So for instance, if you have an int a, you cannot store any infinitely large number in this variable a. There is an upper bound to that. That constraint is enforced by the programming language. So that's basically because in the computer, you have a CPU and you have registers. So one register can only store a certain large number. It cannot store anything more than that. And that typically dictates the size of an integer. So here the problem is, if you take a factorial of a big number, let's say 20 factorial if you're doing, then this might become a very, very large number, a number which you might not be able to store in a single integer variable. This is just a constraint that is enforced by the programming language. There are bigger data types like long int. Even those data types, you cannot store such a large number. Do I have to explain this, why you cannot store in double click on this, or is it fine? Do you get it at a very high level? Where are the others? It's fine, right? So everyone, right? Gautam, it's fine, right? Kush, is it fine? Nikhil, is it fine? Abhishek Patwardhan. It's a nice name. Fine, right? Okay. So then we can basically, Aman, do you understand this? You come from a Python background, right? Okay, Drisan, do you understand? So, so then how do you do this? So one idea is basically that if you want to compute n factorial, you can, you want to do this product basically n into n minus 1 into n minus 2 into n minus 3 and so on till 1. This is what you want to do. So you know that this product can start becoming large enough for an integer to be able to store it. So what you can do is you can keep this running product. Let's say you have already computed the product till here. You can keep this product in an array. So where each cell of this array is a digit. So this is a digit. Let's say this is 2, this is 5, single digit, 7, let's say 9, let's say 6. And then now you are at n minus 3. Can you multiply n minus 3 with this array, assuming that this array is basically representing a number? So this n minus 3, let's say it is 18. How do you multiply this algorithmically? This is the old school method of multiplication. How do you do this? I mean, old school as in whatever you have already learned in your schools. This is 20, let's say. How do you multiply? By product and carry, right? So how do you do this? This is one digit, right? This is the least significant digit. This is the least significant digit. This is the most significant digit of the number. So think of this as a number, 25,796. And it's just that we have stored it in an array. And you have a number with which you want to multiply. And the result, you need to store it in an array. Okay. How do you do that? You can do 20 into 6, which is 120. What do? You do a 120, you do 120 modulo 10, right? That is 0. So 0 you copy, and everything else, what is everything else? Which is 120 by 10, right? Which is 12. So 12 you carry here. And then you multiply 20 by 9 and add it to 12. So 20 into 9 is 180. 180 plus 12 is 192. Now again, 192, you don't take the entire 192. You take only the last digit, which is modulo 10. So you take 2 and you put it here. And the remaining, which is 19. How is 19 computed? 192 by 10. So it is 19. This 19 you again carry here. Right? This is how you multiply in schools. Now 20 into 7 is 140 plus 19, 159. So again you will do 9. 15 you will carry. And 15 you will carry here. 20 into 5 is 100 plus 15, 115. 5 you will write. 11 you will carry. 20 into 2 is 40 plus 11, 51. 1 you will write. 5 you will carry. Now whatever is left, you will just copy it down. So you have 5. This is not needed. This is basically the answer. So can you multiply an array with a number using this technique? Do you understand this old school multiplication algo? Right, everyone? Can I have acknowledgements from everyone to know that you're not sleeping? If you get bored at any point in time, let me know. We can do a puzzle. People from CS, non-CS, maths background, mechanical background, do you understand this multiplication method? Do you understand this modulo 10 and by 10? Right? So this is what we will be using, nothing else. So what we will do is we will take the nth number first. We will initialize. So this algorithm will proceed in 3 stages. We will basically initialize first. How will we initialize? We will take an array. Let's say we want to do 20 factorial. Okay. So we will take an array, and what we will do is we will copy digits of this of n in this array in reverse order. So that the least significant digit comes here and the most significant digit comes here. That's what we will do. So 20, we will copy the digits in reverse order if we want to do a 20 factorial. So least significant 20, 0 will come here and 2 will come here. Okay. That will be the array with which we will start. Now what we will do is so this will be the array. So you can read this 20 in reverse. Now what you will do is you will iterate from 19 to 1 and you will multiply. So what you will do is you will pick up numbers. So first you will pick up 19 and you will multiply 19 with this array using that technique that we are talking about and create another array. So how will we do that? We will multiply this with this first, right? Because this is in reverse, remember. So we will multiply this with this first. So 19 into 0 is 0. There is no carry. So 0 is carried. Now 19 into 2 is 38 plus 0, which is 38. I will carry 38 and the more I will just copy 8 here. 3 will be carried. 3, I don't have anything else. So I will now copy 3. Right? This will become my array after multiplying 20 by 19. Now I can continue this with 18. Again, I will follow similar technique. I will get another array and I can keep doing this till 1. This is the algorithm that I will be using. Right? Make sense, everyone? Yeah. Now you see how neat code can be written. You don't really, this will not be very dirty code. I will just, so now you can follow along. Just see my screen and you'll be able to get things. So this is the screen and I have to compute this. So I will first initialize a vector. This is the initialization. Okay, should I increase the font? These two steps. So I will initialize it. And the way I will initialize it is I will have a vector which will be my result. I don't have any element right now in the result. First I will initialize it. How do I initialize it? I have an iterator. I will extract digits of n. How do I extract digits? I run it from n to 0. I keep dividing it by 10 and I keep taking the remainder, which is basically nothing but the digit. So I will do and pick I for 10. So this gives me one digit, right? And I will now add that element to temp. So remember, this is an empty array. I have not created, this is an array of size 0. And I have just created an element in that array, which is basically one digit, the most significant, the least significant digit first. Does everyone understand this code? Anyone who does not understand this? You can let me know. This line, Rahul? So this is an empty vector result. And what I'm doing here is I am creating one element in that vector, in that array. So this is the value. So pushback is nothing but creating one element, appending one element to the vector. Your question is in this line, Rahul, right? Got it? Yeah. Any more questions? So now I will multiply. What I will do is Yeah. So now what I will do is, I will go from n minus 1 to 1. And I will multiply. I will call this function, don't worry. This will be an infinite loop. Yes, so basically I'm just extracting digits of this number. So let's say you have 325, sorry. You want to extract 5 first. What do? You do a modulo 10. 325 modulo 10 will give you 5, right? So that's what you do in the first case. And then by 10 is basically you are reducing it by one place, reducing the number by the units place. So now you have 32. 325 by 10, what is 325 by 10? 32. Right? So this is I equals I by 10. I assign I by 10. Yeah, I don't need the equality. Yes, it will be an infinite loop. You're right. So now I will multiply whatever result I have with I. This is the actual logic that I want to do. So let's see the actual old school multiplication. This is the result and I need a number which I have to multiply. So I want to use the carry method. I just have this size. So I will start from 0 and I will go up to the last element in that array. I have to multiply that cell with n, right? So I would need two variables, temp and carry. So if you remember, temp will become nothing but whatever you have plus carry by 10, and carry becomes, sorry, this will become basically, so we'll multiply this. This gives me, so I have to multiply result 0 with n, which I am doing here, and I have to add the carry, right? And this entire thing, if I take a modulo of 10, is what I have to copy. And what is my carry? My carry is this. Does anyone understand this, what I have done so far? This will be the wrong answer. No, yeah, it's not complete. I have to copy the remaining carry. That I will do. Why are we multiplying by n? So this is basically the multiplication method, Tanya. So if you see, what did we do here? At any step, if you see, how are we multiplying? We are multiplying the current. This is n, right? And this is nums of I or result of I, whatever you are using. So you are multiplying result of I with n and you are adding carry to it. and you are adding carry to it, right? This is the total product. And then what you are doing is you are only copying the modulo 10 part of it here. And by 10, this entire things by 10 becomes the carry for the next round of iteration. I will show the code again. You can convince yourselves that this works. This is not complete, but let me know if you don't understand this. RESI will be updated, Simran. That shouldn't be a problem because we are not using RESI again. Oh, RESI is already updated, you are saying. This thing. इसको नीचे कर लो. Is this fine now? And what I will do now is I will just copy over the remaining carry. Right? So whatever carry is left, I'm just copying over that entire carry, copying the digits of it. I am pushing back because my array is of size k, which I have filled completely. Do you want me to take an example to explain this, dry run it, or is it fine? What? Yes, sir. Is it, do you want me to take an example? Is it fine? Fine, right? Tanya, are you following this? Yeah, so this loop is just carrying the, okay, let's do an example. So let's see, let's say, just see this code only for the example. Let's say I have an array wherein I have 1, 4, 0. So not 140, 143. So this is actually 341 in reverse. So result has 143. And let's say I want to multiply 12 to it. So n is 12 and result array is 143. The number actually is 341. Okay. So how do I multiply this? I will first do carry is 0 to start with. That's critical. So carry from the left, you are not getting any carry. So carry is 0. Okay. So when you are multiplying, you will multiply 12 into 1 plus 0. So this entire expression is nothing but that. It is 12 into 1 plus 0. 0 is coming from the left, which is 12. Now you want to, what do you want to populate here? Just 2, right? Which is modulo 10. So temp is storing that, just 2. And modulo 10 and by 10 is basically 1, right? 1 you are carrying forward to the next. So you are updating your carry now. So carry is 1 now. Now you multiply 12 into 4. So what is the product? 12 into 4 plus 1. 1 is the carry that is coming from the left. So that's the expression 12 into 4. So this is 4 into 12 plus 1 carry coming from the previous iteration. So that is 49 and 49 modulo 10 is 9. So you, because that's what you want to copy. You don't want to copy 4 and 4 you want to carry. So 49 by 10 is 4. 4 is carried over for the next iteration. Now 12 into 3 is 36. 4 is coming from the left, 40. So 40 modulo 10 is 0. 4 is left over, right? 4 becomes carry. Now in this loop, I am just copying whatever is left in the carry in reverse order. So I am extracting all the digits of carry and just expanding this array. So this array was of size 3 initially. It is still of size 3, but I know I need more digits. So I'm pushing back 4 now. And then by 10, 4 by 10 becomes 0. So I is not greater than 0. This loop exits. Is it clear? Tanya, do you understand? The second for loop is just for extracting the remaining digits of carry. So carry, after you do the last multiplication, there will be carry which is left, right? That carry you need to add that carry also, right, in the array. And because the entire array is reverse, I will again extract the digits of carry in the reverse order and put it in this array. That's what we are doing here. How are we taking 143? No, this is just an illustrative example. 143 is coming, let's say n was 143. So that the first number, I mean, this is just an example. So I'm pushing all the digits of 341. 341 was the actual number. I'm pushing all the digits of 341 in reverse order in the result. Do you follow, Subrasili? Okay, so now this is done. Now what do I need to do here? I will just need to print result in reverse. That's it. So I can print it. How? Result dot size -1, I greater equals 0, I minus minus. I can just. Do you understand why I have to print it in reverse? Because I have done everything in reverse. No. Now you can ask me questions. Please unmute and ask me any question that you have. I'll just take a pause. No questions? Everyone is clear? Yeah, I can scroll down. These codes will be made available to you, don't worry. But yeah. Yeah, we could have. I mean, many ways of doing it. You could have multiplied from 1 to n. You could have not stored it in reverse, but then you will have to, yeah, that also you could have done. So all people with errors in their codes, you can paste it in the Slack channel, and I guess someone will resolve it. I can also take a look. Okay. You can take a very large array, like an array of, let's say, 100 to or maybe 10 to 1,000 cells, and you can it's just the analogous part of this, and you can store in reverse, store basically from n minus 1. But I like this because I can append to the back. Otherwise I will have to prepend to the front, or maybe take a large enough array where I don't need to prepend. But yeah, cout is a way of outputting. So this is printing the result to the console. Printf. This is just syntax. Cout less, and this is end line is just a new line, right? Any more questions? So just make yourself comfortable with codes. My objective for today's class is to actually make you comfortable in understanding and writing codes. Yeah, that will be a little complicated. You're right, Simran. That's why I'm not doing that. All right, can I have acts from people to move on? Permission to move on? Yeah, no one has any issues. Please stop me if there are any issues. Okay, let's do a puzzle now then, and then just to, make a simple puzzle. So we will do puzzles every day. This actually, puzzles are also an important part of interviews, and more emphasis are being put on puzzles these days. So we will do a puzzle every day so that you have enough practice for puzzles also. Puzzles are just random ad hoc entities. If you have done it, or if you have seen similar questions, you will be most likely to do it. If you are not, then it is not a comment on your credibility or your intelligence at any point in time. It's just ad hoc. So let's do a puzzle. This puzzle is actually simple. So you have 3 jars, J1, J2 and J3, and so all the 3 jars are mislabeled. What does that mean? So one jar basically contains only oranges. So it's the time of corona virus. So oranges are important supplement in your diet for vitamin C. So one jar, your mom filled it with oranges, let's say. Then another jar, let's say it was filled with apples. And one more jar is filled with oranges plus apples. So it's a mixed jar. What you have now, so this is the composition of these 3 jars. You don't know which fruit or which composition is in which jar, but you know that all the labelings are all the jars are mislabeled. So one jar is labeled as oranges, one jar is labeled as apples, one jar is labeled as oranges plus apples. So the jar that is labeled as oranges definitely does not contain only oranges. That you know, that is a mislabeling. It contains either this or this. Similarly, J2 does not contain only apples. It contains either this or this. J3 does not contain this. It contains either this or this. Okay. What you have to do is you have to tell me how many minimum number of fruits you need to pick in order to label the jars correctly. Do you get the question? Do you guys get the question? Others, do you get the question? Yeah, tell me. Think about it. The crucial thing is that it's mislabeled. All the jars are mislabeled. Yeah, can someone unmute and tell me why it's 1?
One.
Yeah, how?
So basically we pick one from the oranges and apples jar, the third jar.
Mm-hmm.
So, and we suppose it comes out to be apples.
Mm-hmm.
So oranges and apple, jar 3 is apples.
Mm-hmm.
And we know jar 2 cannot be apples.
Mm-hmm.
So jar 1 will be So basically jar 3 is already apples, and we know jar 1 cannot be orange. So jar 2 will be orange and jar 1 will be oranges and apples.
Yes, as they are all mislabeled.
Yes.
Yeah, that's right. So Akash, you have 3 jars, 3 types of fruits. One jar only oranges, one jar only apples, one jar apples plus oranges. All the jars are mislabeled. So jar J1 does not contain only oranges. It contains either apples or it contains apples plus oranges. Similarly, jar J2 is also mislabeled. It does not contain only apples. It contains either only oranges or it contains oranges plus apples. Similarly, jar J3 does not contain O plus A. It contains either only oranges or only apples. So these jars are mislabeled. I will go and pick up one fruit from jars. You have to tell me how many minimum number of fruits do I need to pick in order to label them correctly. I need to find out which jar has what. That's the question. And the solution to that is that you need just one. How? You pick up one fruit from J3. Okay. So J3 is labeled O plus A. So it definitely isn't O plus A. It is either only O or only A, right? So now you pick up from J3. Whatever you get is the labeling of J3, right? If you get orange, then you know that J3 is only O. If you get apple, you know that J3 is only A. Okay, so J3 has been labeled correctly. Now use that inference to label J1 and J2. How? You know that J3 has only oranges. So now come to J2. J2 definitely does not have only apples. Now you know that J2 also does not have only oranges because only oranges is in J3. So J2 has O plus A. And what is left? A. So J1 has A. Similarly, if J3 has only apples, then you come to J1. You know that J1 cannot have only oranges. It also cannot have only apples because only apples was found just now in J3. So J1 will have O plus A, which leaves J2 O. Right? This line of reasoning you can do. This is simple line of reasoning, but these are important things in interviews. Should I explain it again? Does everyone understand? Okay, let's move on. So this was it's 10:30, right? Let's do more questions. So I just want to do questions today. Tomorrow we can start with time complexity. Let's do some heuristics first. So let's do this question. I guess I can give it to you for practice. Just see this. You can do it. Yeah, this is easy. You guys will be able to do this question on your own, or shall we discuss this? Are you guys there on the other side? Okay, let's discuss. What is the question actually? It's been a while since I coded so much. Like offices, you don't code so much. Okay, this is also the similar idea, right? This is also the running, similar, keeping the running and resetting. You want to take time, everyone? I have no problems with giving you time, but it's just that people shouldn't complain that the sessions are slow. Okay. If anyone has any issues with respect to this, please message me. Otherwise, yeah, please go ahead and do this. Just put an ACK here once you are done. It's 10:30. I'll give you 5 minutes. 10:30.
Sir?
Yeah.
I'll talk
Yeah,
about
tell me.
these approaches in detail so you will understand.
Hello. Yeah. Somebody wanted to tell something?
Yes, sir. So I was thinking like first we take the array. So the array has n elements.
Mm-hmm.
Okay. So we divide n by 4 and store that value. So as we can see, the array has the element which has more than 25% of array. Okay.
Mm-hmm.
So we start from the first array input, the first element n is equal to 0.
Mm-hmm.
And then we check the n is equal to n by 4,
Mm-hmm.
capital N by 4. So we basically check those values. The moment those values come equal, because the element which is 25% of the array will be repeated 25, matlab the 25% of the values will be that array number.
Yeah, that's pretty much, yeah, that's the approach. I mean, these questions, if you see, they are not very heavy on algorithms or logic. They are mostly to get you acquainted with writing code. That's the reason we are taking these questions. So yeah, saying and code it, then you will maybe realize, I mean, get more practice. So others who are still thinking, you can just keep the count. So you want an element to appear more than n by 4 times, you know n, right? N is the size of the array. And you want it to appear more than n by 4 times. Why don't you count every element? Like how many times it occurs? How do you count every element? Because it's sorted, can you just count in a contiguous fashion? Similar to the idea that we've been using all along, which is basically running. You just keep counting as long as you are encountering the same variable, same number. As soon as you encounter a different number, you reset the count to 0 and check for the previous count, whatever you have counted. If it is n by 4, you return that. Otherwise, you can restart the count again, right? Similar to what we've been doing all this time. Shall we do this question? Are you able to see the lead code screen? Yeah. So let's do this. Just follow along with me. I will first count Are you guys following along, or are you still doing it? Do you need more time? Hello. Shall we code? Right. So, yeah. So you need an element to occur more than n by 4 times. So let's say k is n by 4. Now this is the idea. I will just use a previous element, which will basically tell me the running number which is there. Okay. So I can start from 0 and I can go till n. What do I do here? Let's put some dummy value. It's okay. I will check if the current number is equal to the previous number. And you have the count, the running count, which is 0. Okay. If the current element is equals to the previous element, then I can just increase my count. But the only thing is, if I don't have a previous element, I can keep updating the previous element to this, right? So this is the running sum. So I'm just checking if the current element is the same as the previous element, I am incrementing. Or the boundary case is that if my previous is -1, which means that I don't have a previous element, then also I'm updating my count and my previous keeps on remaining the same. Now in this else, once I encounter an element which is different, then what do I need to do? I can check the count. If running count is more than n by 4, right? Or more than equal to, it's more than. So if I do greater than k, then I can simply return the previous element, right? Otherwise, I can reset my running count to 1 and I can set my previous to this number, correct? And I can return, and finally in the towards the end, I haven't checked for the last number, right? The count of that last number, because I don't have a previous. So I can return. If I haven't encountered, it is given that there is exactly one integer. So it always occurs. So you don't need to actually do any sanity check. You can simply return previous here. Oops, I did it in the, so this is the code. Is this fine? Did you guys check this code out, or are you guys still doing on your own? Because we have one element, Meghank, here. We already have one element, right? This previous. To start with, we didn't have any element. You can start it with array 0 and run count as 1 and start this loop from 1. That is also fine. So are you guys now comfortable in writing code somewhat? Last step, Akash, which one? The final return you are talking about, or this else? So the final return is this else, right? So once I have encountered a different element, then I will check the existing, I have counted all the numbers, right? Till now. I will check if that is greater than 25%. If that is, then I can return that, right? Otherwise, I have a new element. Right? Anyways, now, so that new element becomes my previous. Basically, this element is the running element now, for which I will be comparing. And my count is 1 because this element is there now. So now after that, the I will be incremented and you move on to the next element. And you will check if it is equal to the previous element. Just dry run this once in your head and you will understand. Right? So now you are comfortable in code, right? Writing code at least somewhat. So you can practice more. I can share with you the first practice problem, which has 10 questions. practice them. So that will give you more idea on how to go about writing code. And then we can, from tomorrow, we can start with time complexity and binary search. I just wanted to give you a feel of writing the codes because that is very important. What time it is? 10:43, right? Okay. Is everyone cool with it? Yeah. All right. Okay. So then we can meet to. So what time do you want to fix this session generally? 8:38. 8 works for everyone. Okay. If 8 works for everyone, we can have 8. Roughly 3 hours, Mrigank. I mean, it will depend again on your grasping power as well as the syllabus that needs to be covered. So we have 26, 27. Right? 8. Okay, let's freeze 8. Let's quickly finish off time complexity today so that we can start binary search tomorrow. It will take at least 2 lectures to cover binary search for your batch. Like, okay. So yeah, so let's finalize 8 then. 8 is fine. So now I will just go through time complexity and space complexity very briefly so that all of us know what it is at least before we can start the real stuff. So now you remember we told that programs are executed on computers. So every program will take some time to execute, right? So for instance, why will programs take time to execute? Because it is a set of instructions, right, which are executed one after the other, and instructions will take time, right? So this will also depend on the CPU clock, CPU frequency. Basically, if you have a 2.7 gigahertz CPU, then it can execute a certain number of instructions per second. That is typically determined by the CPU clock. That will also determine how long your program is taking to execute on a computer, right? So programs take time to execute. There is no doubt about that. For instance, if I take very simple example, let's say if I take int x assigned 3, and I'm just printing x, which is cout. Somebody asked what is cout. Cout is just printing. This is a syntax. And so this is, let's say, the program. And let's say I'm saying that every instruction, this instruction is taking 1 second. Then in all, you are basically taking 3 seconds for this program to run, right? Because instructions are executing one after the other. So programs take time to run, and we as programmers want to write code which are efficient. What do we mean when we say which are efficient? We as programmers want to write code which run fast. Obviously, fast codes are always good, right? Why are fast codes good? Because they take less time. So we want to write programs which run fast. Now, there is no doubt about that. So for every program, thus, whatever program we write, we need a tool. We need a tool or an aid basically to measure how fast that program is. But that measurement should not be really tied to the CPU. It should not be exact like 2.3 seconds this program took. We want an approximate measurement of how fast that program runs. And that is where time complexity analysis comes into the picture. So we say that we can analyze the execution time of programs using this time complexity analysis that we have. So far so good, no rocket science, all plain English. So one thing is, you have a program, right? We want to measure programs in terms of the size of the input that you give to the program. So for instance, if you give an input which is, let's say, of length 10, we want a way to know whether the program runs in 2n, or does it run in n square? Does it run in n cube? What does that mean? That means 2n. What does 2n mean? 2n in English, 2n means that this program takes twice the time, the size of an input. So roughly for every input, it takes twice the time, right? Similarly for n square, what does that mean? That means that this program takes n times the size of the input to run on a computer, right? So we want this analysis to be done based on the size of the input, because that will determine the speed of a program, right? If you have smaller inputs, your program will run faster. If you have larger inputs, your program will run slower, right? So you want your programs to be analyzed in terms of the size of the input. Do you get this point? Why we are stressing so much on the size of the input? Yeah, because programs inherently are tied to the input, right? How you don't know how big the input is. If the input is very large, program will take longer time, right? But when you want to compare programs, you want to compare them independently. So you don't want to say that a program that ran on an input of size 3, you don't want to compare that with a program that ran on a size of input 10. It's not fair, right? Because P2 will, even if P2 is a better program, let's say by a factor of 2, then also it will take more time than P1. But that's not a fair comparison, because P2 had an input which was of a larger size. So we want to quantify the time that P1 takes in terms of the size of the input that P1 has, and P2 also in terms of size of the input that P2 has, and then it will be a fairer metric. Then we can actually compare P1 and P2 on a scale. So for the same size input, for an input of size n, let's say, we will say P1 took n square and P2 took n cube. So then we will say, oh, P2 is slower because P2 took n cube. But for that, we have to fix the size of the input. We cannot just say P1 runs faster than P2, right? Because both of them are tied to the input of the program, the speed of the execution of the program, right? That's why in this programming world, there is so much stress on the size of the input, and all the complexity analysis as well as the space complexity analysis being closely tied with the size of the input. So we want a tool to, so far so good, we want a tool to measure the complexity of a program in terms of the size of the input, right? So now, and we don't want to really get into the details of things as in we don't really want to micro calculate this speed or this time. We just want an approximation. So what we say is, okay, we have certain notations for this. I will just give you an intuition of the notations. We will not go into the maths of that because that frankly is not needed anywhere. It's just there for the purpose of being there. So we want to capture an upper bound on the time that a program takes to run. So we want to say that, hey, this program will not take anything more than this time. So that we capture by the big O notation. Similarly, we want to capture a lower bound on the time that a program takes to run. So we want to say, hey, this program takes at least this much time. So that is being captured by the small omega. And then we want to capture an approximate time. So basically we will say there is no bound. This is roughly approximate, which is captured by the theta notation. So theta basically tells that this program runs roughly, takes roughly this much time. So if you say, for instance, if you have a program P and you say that this program has O5, let's say, I'm just cooking some. So that basically in English means that this program does not take more than 5 units of time, whatever unit is there, does not take more than 5 units of time to run at any point. Similarly, if you have omega of 5, you are saying that this program takes at least 5 units of time to run. And if you have a theta, you say that it is the time that the program takes to run is approximately 5 units. Okay, so these are just some tools, some notations that we use to capture the speed of a program. So this is just a mathematical notation that we use to capture the speed of a program. So far, so good. I'm just trying to give you the intuition. Tanya, are you following? Are you there? So far, so good. Yeah. Okay. So now, so we have these notations. Yeah, I mean, this is a big O, this is big O notation. This is omega. And this is theta. But again, we typically, this is all that we need in our programming world, like at least for interviews and for working in the industry. These are like, we don't really need that because we just want to define an upper bound for programs that, hey, this program does not take more than this time. So then I guess we are good. So the intuition behind this is that in industries, you have a certain capacity, right? You cannot exceed that. You have a cap on things, on the time, and that big O captures that only for the program, right? It intuitively in English says it intuitively in English says that this program will not take more than this much time. And that's what you want to know in the industry because you cannot exceed that time. That's what is needed. Other things are mostly like not really needed. And all these functions, these are all take the size of the input as a parameter. So for instance, if I do big O of n square, so this basically means that this program is upper bounded by n square. So what does that mean? That means that if you take us input of size n, it takes roughly, it cannot take more than roughly n into n time for running. The big O is time constant, right? What does that mean? Time constant. Maybe you can unmute and speak. That might make. Okay. So that is basically the big O notation. So we want to do, I mean, for articulate all these speeds in terms of the size of the input. That's one thing I told you. And the second thing I told you is there are certain notations that we use to capture the speed of the program. And these are these notations. We want, if we want an upper bound on the speed of a program, we use the big O notation. If we want a lower bound, we use this. If we want a tight bound, this is called tight bound. Tight bound is basically roughly in that area that the time is. So we use a theta notation. So this is just some mathematical notation we use to quantify the time taken by a program in terms of the size of input. And in the first point that I told you, that the importance of measuring the speed of program with the input as a parameter. Okay. So roughly, for instance, I will give you some very simple. We will not really go into master theorem right now. We might go into that when we do recursion. But roughly, if you, for instance, if you have this kind of a program, let's say you just have x assigned 3, you have c out x, and you have return 0. So this basically is 3 instructions, right? So this is basically, you say that this is order 1 or this is constant time. Why? Because this is not related to the input, right? So let's say your input is n. If you have a program that just does these 3 things, let's say you are taking an input n and your program main is just printing this. So the complexity for this program, we say, is order 1. Basically, it is constant time. It does not take any time in terms of input. It does not take any time because it is not dependent on the size of the input. No matter how big n you give, it will always take a constant time, which is just running these 3 instructions, right? It is not dependent on the size of the input. Correct? On the other hand, if you take a program wherein you are taking n as an input, and let's say you're running a for loop in that program, and let's say you are outputting something. Now this program takes order n time. Basically, we say that this program in terms of n, if n is the size of input, this takes n units to run. Why? Because in the first iteration it does a C out. How many times it does a C out? C out, C out, C out, n times, right? So this is an order n time program. In the for loop, let's say if I have 2 C outs, let's say I'm printing I also along with n, let's say. So then what is the complexity of this program?
Two n.
Yeah, 2n roughly. You are taking 2n time. And what is this in terms of n? You can still say this is order n. Why can you say this is still order n? Anyone? Because the degree is still n, because 2 is constant, because n is quite large. So just what do you mean when you say we consider power of n only? Yeah, Rahul, you are right, because these n are quite large. Because it's an upper bound, we want to so this is a homework for you guys. Come back to me tomorrow. Maybe you can do some research and some reading up. We will tomorrow, we can, in the first half, we can formally, I was just trying to give you an intuition on the big O, omega and theta today. Tomorrow we can formally define these for the sake of completeness, and then we can basically analyze complexity of programs using this tool. So that's basically what we will do tomorrow. In the first half, we will start binary search after that. So this is left to you as an homework. Just think about this. My question was very simple. I just told you that let's say I have a program of wherein I have an input of size n and I run a for loop. In this for loop, I do see out not one time, two times, or let's say three times, let's say four times. What will my big O, what will be the time in terms of big O? If it will be big O of n, why? If it will be big O, if not, what else will it be? Okay, do you get the question? Yeah. So just think about it, but do you at least have some idea now on the time complexity? Like at least the intuition. I just wanted to give you an intuition on what big O, what theta means, because that's something not many of us know. All right. I think it's 11. You guys must be tired. We will continue tomorrow, 8 p.m. right? 8 p.m. was agreed upon by everyone. Okay. 8 p.m. then we will meet tomorrow. If you guys have any more questions, I am here for some time. Otherwise, you can leave. Thank you all for joining, and we will meet again tomorrow. Yeah, I will give you the credentials, the lead code credentials, and you can log in and see all the codes for yourself. Okay. यार कॉन्टेस्ट हमेशा रहेगा, अब क्या करे, वो है बताओ. मतलब वीक में 3 दिन कॉन्टेस्ट होता है, फिर कल सुबह रखोगे क्लास? तो यही बात है ना, मतलब एवरी डे, एवरी अदर डे 3 कोड फोर्सेस तो वीक में 2 बार होता है, बाई वीकली होता है, तो फिर कैसे होगा? फिर जल्दी कर लो, मतलब आप बता दो मेरे को, आई हैव नो इश्यूज if you want it early or if you want it at some other time. I will share the DPP on the Slack channel. You can practice. So those are basic array questions. Yeah, we'll keep it at 8 only. Contests, you will get it. I will tell the operations team to mail you or put it in the group. I will just call them after the meeting and tell them. Okay, they are entitled or in charge of this. Okay. All right. If there is nothing else, thank you all for joining. It was great talking to you, meeting.